whenever you get an edit, this cool icon will show up now. So it was totally worth all the time I spent. But now we can turn these icons into badges, so there's just something to look for in the game. So all we gotta do is click here, here, and then upload an image, and give it a name, and then pay $100 for one badge. Yeah, so I made 7 badges, and they're actually pretty easy to implement in the game. So we have badges that you can work with. Next up, we had another problem. One of our player would play the game and then leave. They can join back, they're getting it. But luckily, in the last game I made called Event RNG, which you should play right now. Within that game, I actually made a module for saving player data. And then, like the great Houdini once said, I would never make player data disappear because then the game wouldn't be as or something like that.
Everyone, good evening. Today we are connected for a workshop which we are going to just start in a few minutes. So few we are waiting for a few more uh, participants to join. So after 2 minutes, we'll be starting this presentation. Thank you. So good evening, everyone. Once again, we are going to start this presentation. So I'm Divyajyoti Mishra from STEM Robot Technologies Private Limited. And today we are going to discuss about a topic related with the concept of how STEM or integrating the STEM concept into the academics so that we can develop a 21st century skills among the students. So if I talk about the meeting agenda today, in this workshop, what we'll be covering is a little bit description about the STEAM, what are the different 21st century skills, how we can develop those skills among the students, What is the first principle thinking, and how we can apply the principle thinking in the education process. The next topic that we'll be covering is a design thinking process through which we'll be discussing how we can apply it in different uh, uh, experimentation or the project development part. And then the last will be leveraging technology in the education domain. So I hope my voice is audible to every one of you. If I'm properly audible, please type yes or Y in your chat box. Thank you very much. So we have participants from all across the India which had joined from this for this workshop. Thank you very much. So if you have any doubt, our team will be in contact with you, and you can put a message over there, and we'll be discussing after the end of a session. So coming to the next part, like after covering the agenda, what we are going to discuss is about the STEM or STEAM. Okay, so STEAM is an acronym for science, technology, engineering, mathematics, and when the art is included as a tool, we call it STEAM. So basically, if you talk about these subjects, usually what happen in the school that science and mathematics run as a part of an academic curriculum, right? But nowadays we have seen that students are so much into the field of technology. They are having the access of mobile phone, high-speed internet. They are browsing different concepts from on the internet, and even whenever they visit any mall or any spaces, there is a technology all around them. So in this technology, what what we have seen is that students are quite capable of executing or using these technologies. But the major gap that we have noticed is that they don't understand how science or mathematics concept is being utilized in creating those technologies. So this is what STEAM is all about. STEAM is not four subject or five subject, that is science, technology, engineering, art, or mathematics. It's a combined inculcated subject which can address all these things in a combined manner so that a student can understand the scientific concept in a deeper manner. At the same time, they can understand the application of those concepts in a real world scenarios. So this is what STEM is all about. So to explain this concept a little bit deeper, let me share a small video with you, which will explain this STEM concept in a better way.
What is STEM? STEM.
I hope voice is audible for this video. So can you please share yes or why? Okay, thank you.
Is not just a subject at school. It's a way of thinking and doing, and an important skill set that could see your generation working together to solve some of the world's greatest challenges. STEM stands for science, technology, engineering, and mathematics. But it's not about being an expert in all of those things. Instead, it's about harnessing the essential, transferable skills behind them. Scientists know how to hypothesize, experiment, analyze, and evaluate what they discover. Technology can make our lives better. Designers of all sorts work together to make everyday tasks more effective and more fun. Engineers don't just wear hard hats. They are problem solvers that work on some of the world's biggest challenges, like creating bionic limbs for people with disabilities or exploring outer space. Mathematics teaches us how to quantify data and how physics rules the world around us. With mathematics, we can implement change and minimize error. You won't have to master all of these skills either. Teamwork is an essential STEM skill. Take the search for new energy sources, for example. Geologists and geophysicists search for gas deposits. Engineers help you design and run platforms and processing plants. construction teams work to build essential infrastructure under the supervision of project managers, and environmental scientists work with everyone, every step of the way. Playing to your strengths and working in a team will have you creating a greater impact than if you...
So as you have seen in this video that it has given an explanation of the STEM concept, that it's not required that everyone become a expertise or expert in their definitely fields, right? STEM is all about collaboration. So when you have the proper awareness of these concepts, what is the practical application of the science concept or mathematical concept in a real world scenarios, it will be easy for you when you move toward a corporate culture or somewhere where the project has been people are working on different projects. Because as example has been given that construction project has been happening, so the engineer's job are well defined, but to make this collaboration more in a easier way, STEM provide a tool because it will create a awareness among every member of the teams that this will be their KRA or this will be their roles and responsibilities. And if they have to collaborate with other teams, they will have a basic understanding of these concepts. So that is a very important part when we talk about STEM. STEM, most of the concept that when we talk about STEMs, sometimes it happens that getting the understanding of a robotics or understanding of artificial intelligence is only the STEM all about, but it's not. STEM is having a understanding or deeper understanding of the principal subject, like a core subject, okay, so that you can relate it with the real world scenarios. So that is what STEM is all about. Coming back to the presentation now, what are the application of these things? Like when we talk about STEM, where are we going to use it in a real world scenarios? So as a teacher or as a educators, when you are delivering a content to a students, right, your focus should be that the concept that you are teaching to the students is more relatable to them. You can give them some relevant examples while teaching the concepts where they can visualize those things, application of those concepts in a real world scenarios. Like for example, like you are teaching them a light subject, okay, so you can give them a relevant examples of mirrors. You can bring small objects or small TLM teaching materials in the of in your live class, and you can show them those activities through a experimentation process. So what will happen that at the same time, because the students, when we talk about science or mathematics, why they have a phobia around these kind of subject is that the most of the things are concepts are in a theoretical, you can say, definition format, so they are not able to visualize those concepts in the real world scenarios. But if you do a small experimentation in front of them and can relate those concepts with the real world application around the world, where they can see the application of those concepts happening across their surrounding, then those concepts get more clear, those definition get more clear, right? Like if I talk about the science or mathematics, there is a phobia among the students that they feel it very difficult to understand the mathematics. But if we make those mathematical activities in a fun game where they can visualize that like successor and predecessor, this is what we teach to the students, right? Or congruency in the 10th class, we teach them about the triangle and different congruency. So if they can relate those concepts that the chapatis made by their mothers are similar in shapes and sizes, so it's a concept of congruency, right? So if they can relate those concepts in a real world scenarios, those definition give a more valuable concepts. So that is a core focus of these STEM or STEAM education in a academics, where you can make the learning experience for the students in such a innovative and you can say collaborative manner, where they can understand these topic and at the same time get a relevant examples of those concepts in a real world scenarios. Now, the focus of this STEM education is to develop the 21st century skills, which is very much required for the students, right? So if I talk about different 21st century skills that need to be developed among the students, because you are seeing that technology is developing rapidly. Okay, in every 6 months, new concepts, new technology is coming, which is revolutionizing the whole industry. Right now, you might have seen the example of Chat GPT or large language model that is there, right? You write down any question or any topic, and it can give you the whole complete essay or complete answer of that question. So that is a application of a real world example of a technology evolving technology, right? So it's not clear what will be the job structures in the future, because if we talk about the experts in these domains like Mr. Elon Musk, they have given this prediction that after 15 years there will be no jobs, a regular kind of jobs that we are currently having. The whole industry will be revolutionized. There will be automation in a greater manner, but still the like human will have certain growth which they can monetize or have a luxurious life. So for developing those skill set in the future, it's very much important that we focus on the core skills that will be very relevant in the future. So if we talk about those skills, first one is a critical thinking. Okay, critical thinking is basically a process of analyzing the information, synthesizing the knowledge in a particular manner, so that you can make a proper informed decision around any complex topic. Okay, the next skill that is very much important is a problem solving skills. Okay, what happens here that someone is annotating. If you can see, yeah, Divya, if you can block this or remove this. Yeah. So if I talk about problem solving, it's a effective, basically problem solving is a proper way of identifying and evaluating and then implementing a, you can say, solution that can find a proper solution of any problem statement. So there are multiple techniques that we use for solving these problems. Design thinking is one of our technique that we use, and we'll be discussing in later slides like how these problem solutions work. Okay, the next very much important skill is called creativity. Now, when we talk about creativity, okay, the idea comes in the mind that creativity might be something related to the art, but it's not. Creativity is something is like thinking out of box. If you can see the evolution of our mobile phones industry, okay, it's a very good example of creativity. The first mobile phone or telephone that been created by Graham Bell was a such big device that it was kept in a two-room setup. But now you can see our mobile phone, which you are carrying in your mobile in your pockets, is having more feature than a simple telephone that has been created. So it is due to the creativity, because they have analyzed the problem and they have thought out of box, like how we can change the process in a such a way. Like if you can see the evolution, what happens during the first time when the telephone was invented, there was a big honk like shape, and you have to speak in it, and then you have to put something in your ear to listen to the other person who's speaking. Then the revolution has been there. Now the phones is having a dial up system. You have to dial a number by rotating a number, right? You might have seen it. Then the other revolution comes. Now button system has been there, but there's a dial tone. Then other revolution has there. Wireless telephone has been created, which you can use inside your home to talk to anyone. And the next revolution was mobile phone. And then Apple has come and changed the whole industry. They have introduced the concept of touch screen. They have merged different technology like Walkman you are used to for the music listening. Okay, the camera, the DSLR camera was used at that time. They have merged everything in a single mobile phone. Now our mobile has GPS, internet, touch screen, Wi-Fi, multiple such features. Mobile cameras, such kind of mobile camera was not thought of that we can have such kind of resolution in our mobile phone. So those kind of things, what we are doing, it is because of the creativity or thinking out of box. So that is a very core step that need to be developed among the students. Now, the next thing is collaboration. Okay, so as I've shown in a STEM video also, STEM is STEM develops a collaborative skills. Okay, it's not about becoming an expert in the any particular domain, but you have a proper understanding so that you can work in the team. Okay, and for working in a team, you need to develop a very good social skill. So skill is one of also a 21st century skills. So for developing a social skill, the communication play a very important role. Okay, so these are the 21st century skills. If we work on these concepts, what will happen? Um, our our student will be well prepared for anything that happens in the future. So that is our core focus around this STEM education and how we can revolutionize the whole industry so that the schools who are rightly transitioning from traditional education system where the major focus was around the rote learning, now how they can transition to a 21st century schools where they can implement these skills among the classroom so that student can have a better understanding. Now come to the first point of this skills. We are going to discuss it one by one. The first point is the critical thinking. So how we can develop this critical thinking among the students. So let me show you it, show this through a very small video so that you can understand this concept in a better way.
Critical thinking is a term that gets thrown around a lot. You've probably heard it used often throughout the years, whether it was in school, at work, or in everyday conversation. But when you stop to think about it, just what exactly is critical thinking? And how do you do it? Simply put, it's the act of deliberately analyzing information so that you can make better judgments and decisions. It involves using things like logic, reasoning, and creativity to draw conclusions and generally understand things better. This may sound like a pretty broad definition, and that's because critical thinking is a broad skill that can be applied to so many different situations. You can use it to prepare for a job interview, manage your time better, make decisions about purchasing things, and so much more. Now, as humans, we are constantly thinking. It's something we can't turn off. But not all of it is critical thinking. No one thinks critically 100% of the time. That would be pretty exhausting. Instead, it's an intentional process, something that we consciously use when we're presented with difficult problems or important decisions. In order to become a better critical thinker, it's important to ask questions when you're presented with a problem or a decision before jumping to any conclusions. You can start with simple ones like, what do I currently know? And how do I know this? These can help to give you a better idea of what you're working with, and in some cases, simplify more complex issues. Let's take a look at how we can use critical thinking to evaluate online information. Say a friend of yours posts a news article on social media and you're drawn to its headline. If you were to use your everyday automatic thinking, you might accept it as fact and move on. But if you were thinking critically, you would first analyze the available information and ask some questions. What's the source of this article? Is the headline potentially misleading? What are my friend's general beliefs, and do they inform why they might have shared this? After analyzing all of this information, you can draw a conclusion about whether you think the article is trustworthy. Critical thinking has a wide range of applications in the real world. It can help you to make better decisions, become more hireable, and generally help you to better understand the world around you.
So I hope this video has given you understanding what is critical thinking. So critical thinking is basically understanding or evaluating everything in such a manner that you can take an informed decision. Okay. So right now, what is happening? I'm just going to show another video to you, in which it will be taught like how you can improve these critical skills, among the students. Now, it's very much important that right now we are in a digital era. Okay, we are in an internet age. You might have seen the example of reels or Instagram reels or short videos or like TikTok. Okay, what is happening here? Now we want to consume a data in a very short or very precise manner, and sometimes these things are misleading. Okay, so there the different terms are being used. It's called influencer, where they are influencing you to watch their content regularly, right? It's a process of like making you move into the content and understand, make it view more time, right? So in this influencer uh, era, right, you can easily get influenced by any content that those content creator make. So it's very much important for our students to have a proper critical thinking skills where they can analyze whether the decision or the that whatever is being portrayed to them are is there any proof in it or not. Okay, so it has a very good application in the academics like science and mathematics and other subject also, because what happens sometimes we get a very distorted knowledge through the social media. Not everything is correct, right? But if we have developed this kind of critical thinking skills among our students, then those students can explore those topics in a more deeper way, and then they can take their own informed decisions without any prejudice or any preconceived notions. So that is a more important part of this critical thinking. Now, in this video, we are going to explore 5 tips to improve this critical thinking process. So take a look at this video.
Every day, a sea of decisions stretches before us. Some are small and unimportant, but others have a larger impact on our lives. For example, which politician should I vote for? Should I try the latest diet craze? Or will email make me a millionaire? We're bombarded with so many decisions that it's impossible to make a perfect choice every time. But there are many ways to improve our chances, and one particularly effective technique is critical thinking. This is a way of approaching a question that allows us to carefully deconstruct a situation, reveal its hidden issues, such as bias and manipulation, and make the best decision. If the critical part sounds negative, that's because, in a way, it is. Rather than choosing an answer because it feels right, a person who uses critical thinking subjects all available options to scrutiny and skepticism. Using the tools at their disposal, they'll eliminate everything but the most useful and reliable information. There are many different ways of approaching critical thinking, but here's one 5-step process that may help you solve any number of problems. 1. Formulate your question. In other words, know what you're looking for. This isn't always as straightforward as it sounds. For example, if you're deciding whether to try out the newest diet craze, your reasons for doing so may be obscured by other factors, like claims that you'll see results in just 2 weeks. But if you approach the situation with a clear view of what you're actually trying to accomplish by dieting, whether that's weight loss, better nutrition, or having more energy, that'll equip you to sift through this information critically, find what you're looking for, and decide whether the new fad really suits your needs. 2. Gather your information. There's lots of it out there, so having a clear idea of your question will help you determine what's relevant. If you're trying to decide on a diet to improve your nutrition, you may ask an expert for their advice or seek other people's testimonies. Information gathering helps you weigh different options, moving you closer to a decision that meets your goal. 3. Apply the information, something you do by asking critical questions. Facing a decision, ask yourself, what concepts are at work? What assumptions exist? is my interpretation of the information logically sound? For example, in an email that promises you millions, you should consider, what is shaping my approach to this situation? Do I assume the sender is telling the truth? Based on the evidence, is it logical to assume I'll win any money? 4. Consider the implications. Imagine it's election time, and you've selected a political candidate based on their promise to make it cheaper for drivers to fill up on gas. At first glance, that seems great. But what about the long-term environmental effects? If gasoline use is less restricted by cost, this could also cause a huge surge in air pollution, an unintended consequence that's important to think about. 5. Explore other points of view. Ask yourself why so many people are drawn to the policies of the opposing political candidate. Even if you disagree with everything that candidate says, exploring the full spectrum of viewpoints might explain why some policies that don't seem valid to you appeal to others. This will allow you to explore alternatives, evaluate your own choices, and ultimately help you make more informed decisions. This 5-step process is just one tool, and it certainly won't eradicate difficult decisions from our lives, but it can help us increase the number of positive choices.
So as you have seen in this video, these are the 5 questions or 5 steps that we can take to improve our critical thinking. So it's very much important that whenever we are taking any decisions, okay, sometimes what happens in this digital era, there are number of scams that is happening. Okay, so it still need to be understood that if there is any mail or message that is coming to their mobile phone that you have won a lottery of 1 lakh or 10 crore rupees, it's not physically possible because you have not participated in any of those events. So why are you getting this message? Okay, so this is the 5-step process that you can take to take that decision. Like, you can formulate a question, why I'm getting this message? Then you can gather, I have not applied to any of such schemes. Okay, and then you can consider the application. What happens if I click on this link and something happens and my own account get hacked, right? And then by this taking these kind of steps, you can understand that yes, this is not a proper solution or a proper thing to do, right? So in every steps, we have to develop this kind of mindset in the students, okay, so that when they like perceive any subjects also, they can formulate a question, what is happening here? Okay, can you give me a more detailed way of understanding these topic in a better way? We'll be explaining it with one of example in later slides so that you can get an idea like how this critical thinking can be worked, and then take an informed decision. So before going to the next process, to develop this kind of critical skills, now the question arises, how as a educator or how as a teacher you can develop this kind of skills among the students? Okay, so there's one concept that come into the play. It's called first principle thinking. Many of you might have heard about it. Okay, it's basically a scientific way to approach any problem. So coming back to the presentation, so this is a principle that basically is being used by most of the prominent thinkers, like Aristotle has developed this strategy of thinking at a very root level. Multiple researchers like uh, Dr. Feynman, okay, and even the Elon Musk use this principle of first thinking to understand a topic in a better or a deeper manner. So first principle thinking is a basically is a process of breaking down a problem or or a concept in a very simplified manner so that you can understand what is happening behind it. So we'll be seeing one video to where this process is being explained by the Elon Musk, how he has reduced the battery process, because when he started working on a Tesla, you might have know about this Elon Musk, that he is a person that had changed the industry of a automobile, right? He had introduced the concept of EV cars in the system. Before that, the batteries were too much very much costly, and they are not efficient enough to work around with, right? But he come up with a solution of it, and he has make it possible that even in a very luxurious car, their car can go up to the speed of 300 kilometer, and the battery is powerful enough to cover more than 200 or 300 kilometer in a one go. So how he has solved that problem,
And then I
he
think it's
is
also
informing
important.
in this video, which we are going to see in this.
And then I think it's also important to reason from first principles rather than by analogy. So the normal way that we conduct our lives is we reason by analogy. We're doing this because it's like something else that was done, or it's like what other people are doing.
Me too type ideas.
Yeah,
Slight
slight
different take,
iterations
yeah.
on a theme, and it's because it's kind of mentally easier to reason by analogy rather than from first principles. But by first principles is kind of a physics way of looking at the world, and what that really means is you kind of boil things down to the most fundamental truths, and say, okay, what are we sure is true, or as sure as possible is true, and then reason up from there. That takes a lot more mental energy.
Give me an example of that. Like, what's one thing that you've done that on that you feel has worked for you?
Sure. So somebody could say, in fact people do, that battery packs are really expensive, and that's just the way they'll always be, because that's the way they've been in the past. You're like, well, no, that's pretty dumb, because if you applied that reasoning to anything new, then you wouldn't be able to ever get to that new thing.
Right.
It's like you can't say, horses. Well, nobody wants a car because horses are great and we're used to them and they can eat grass and there's lots of grass all over the place, and there's no gasoline that people can buy, so people are never gonna get cars.
Right.
People did say that. And for batteries, they would say, it's going to cost. Historically, it's cost $600 per kilowatt hour, and so it's not going to be much better than that in the future. And you say, no, okay, well, what are the batteries made of? So first principles would be to say, okay, what are the material constituents of the batteries? What is the spot market value of the material constituents? So you can say, okay, it's got cobalt, nickel, aluminum, carbon, and some polymers for separation, and a steel can. So break that down on a material basis and say, okay, what if we bought that on the London Metal Exchange? What would each of those things cost? Like, it's like $80 per kilowatt hour. So clearly, you just need to think of clever ways to take those materials and combine them into the shape of a battery cell, and you can have batteries that are much, much cheaper than anyone realizes. And then,
so what you have understood in this first principle method is basically we are using a principle of science, okay, to break down any complex problem. Like there's a problem in front of a Musk that he has to make a battery pack that is very cost effective. But during that time, the most of the production that being done and the research that is happening in the battery pack, the cost was $600 per kilowatt per hour. Okay, but what he has done, he broke that problem into simpler pieces. Like, what is the battery made up of? What are the different elements that are in creating that battery? So copper was there, lithium was there, zinc was there, carbon was there, and he then take a decision. Okay, what if we purchase it from a market? What will be the value of that component? And the value came as $80 per kilowatt per hour. That if you bought those components and assemble it together at your own place, okay, the cost will be more minimum. So this is how he has applied this first principle thinking in solving a complex problem of a battery that was so much costlier to a battery which is more sustainable and more eco-friendly, cost effective. Similarly, he has applied this principle in multiple of it ventures. Like you might have heard about his one of a venture called SpaceX. Okay, so he has planned to send the missions into space using his own industry called SpaceX. Now, when we talk about this industry of space, like exploration, now the major problem that he has faced was that he the major problem was that the cost of this project was very much high. Okay, if you send a missile or if you send a rocket in the space, okay, you cannot that like million of dollar will be going waste to propel you from the Earth's surface to a atmosphere where it can move around, right? So how he has solved that problem, that what if we can create a booster in such a way that it can separate at different stages and then come back to the launch site so that we can reuse those components. Okay, because for transmitting a satellite, he just needs a small compartment in which he can propel the satellite in the space. The rest of the part is the waste, is a you can say space waste that is happening till now, because these are the projects that is handled by the government only, and they are expending so much amount on them. So what he has done, he had revolutionized the industry, and he thought of a process like, why can we not use those booster again and again? Okay, and from this, the Falcon and different space mission has done where his booster come back to the launch site and it can be used again and again. So this has reduced the cost of the expenditure or space expenditure. So if the students are being if we can teach this kind of thinking process to the students, they can apply these concepts in the real world scenarios, and they can understand these things in a much better manner. So coming back to the presentation, let me show example like how you can as a teacher you can apply this principle in a real world. So like there's a chapter in their science book called renewable source of energy, where they are learning about the wind. Okay, wind turbine and uh, basically the windmill structures. Okay, so if I talk about the STEM concept that being used in creating the windmill, what are the STEM? The STEM is science. The science part is a wind, that the kinetic energy, the wind is moving in a very fast pace, and this movement of wind is causing what? Is causing the blades to move in a particular pattern or in a particular direction. Okay, the blades are designed in such a way that when the wind passes through it, the revolution happens automatically. Now, the what is technology behind it? The technology is the dynamo. So what is happening in the dynamo? When the fan of the windmill move, the dynamo get started, and the kinetic energy of a movement of this wind axle is creating the electricity that is being generated in the technology. Now, what is engineering in this process? Is creating such a huge structure which is very stable and can withstand such kind of pressure, or you can say uh, pressure or such kind of force. Now, if I talk about the mathematics part, the mathematics part will be calculating the value of the power generated, like how the wind energy, which is having its own kinetic energy, is being transferred into creating the electrical energy. So the formula or the concept behind it can be understood in such a way. Now, if we apply this first principle thinking in this process, in this STEM education, now the question will be why the wind is flowing. Okay, so we have taught these topics in the classroom also, but if you ask even a senior students why the wind is moving, they might not be able to give you the answer. Okay. So the first principle thinking teaches us that first ask the question why. Make it more simpler than that. So if we talk about the movement of wind, okay. So why wind is moving? Because there is a pressure difference between two horizon, whether it's northern part or the southern part. Now the question arises, why this pressure difference arises? Now the another part will be the the sunlight is making the, like, one part of our earth is having a summer, another part is having a winter. So in the summer areas the wind is getting lighter and the pressure is decreasing, while in the winter areas the wind are getting more denser and the pressure is increasing. So this create a pressure difference and the wind start moving. So what is the you can say first principle here, that the sunlight that we are receiving from sun is creating the pressure difference uh, i- in our Earth's atmosphere by heating one side up, and another part which is not receiving a proper sunlight during that duration is getting less sunlight, and the weather is getting more cooler, and this pressure difference has been created. So if students start asking this why, and they get to understand the foundation of whatever you are teaching as a science teacher or a math teacher, now they can relate those concepts in every part of their journey. Okay, if their concepts are quite clear, they can apply those concepts in solving different complex problem, understanding the term in a more STEM manner, where they can understand the application of those concepts in a real world scenarios also. So this is what we are talking about, applying the STEM concept in a real world scenarios. Now coming to the next slide. The next process which we have discussed was problem solving. Okay, so we use a process called design thinking approach to solve a particular problem. Okay, so in this design thinking approach, what is happening? That we are we are solving a problem by empathizing with it. Okay, so there's a proper step in solving any particular problem. So if you use a design thinking approach, you can first understand the problem statement by empathizing with that with the person, or by doing a conducting a proper research, you can understand the problem statement. Then you can properly, after understanding that thing, you can properly define what is a problem that we are going to solve, and then the ideation happens. Okay, so we'll be leveraging the technology like robotics, artificial intelligence, coding, electronics, 3D printer, in creating different ideation or prototype to solve that the solution of that problem. And then the next part or the final part is materializing, where you will be working on the final product. So before making this product available in the market, first you have to test whether the problem statement that you have taken to solve and around which you have created this prototype, whether it's working or not. If it's been clear that yes, all the parameter that you have set of for your problems, okay, is being resolved using your product, now you can implement this process in a real world scenarios. So this kind of approach can be taught to the students, and then there are multiple such events and competition that happen across the year. So while they have to create different projects or you can say program around it, they can use this to understand this concept in a much deeper understanding way, and then they can create such kind of projects. To define this design thinking process, let me show you a small video so that you can get this understanding how this design thinking is being implemented.
Design thinking is a 5-step process to come up with meaningful ideas that solve real problems for a particular group of people. The process is taught in top design and business schools around the world. It has brought many businesses lots of happy customers and helped entrepreneurs from all around the world to solve problems with innovative new solutions. Step 1. Empathize. The purpose of Step 1 is to conduct interviews that give you an idea about what people really care about. We need to empathize with their situation. For example, if you want to help old people, you might find that they want to keep the ability to walk around. In your conversations, they might share with you different ways they can do that. Later into the interview, you'll want to dig a little deeper, look for personal stories or situations where things became difficult. Ideally, you redo the process with many people with the same problem. Step 2. Define the problem. Looking at the interviews, you can now understand the actual needs that people are trying to fulfill with certain activities. One way to do that is to underline the verbs or activities that the people mentioned when talking about their problems, like going for a walk, meeting old friends for tea, or simply going grocery shopping around the corner store. You might realize it's not so much about going out, but more about staying in touch. After your analysis, formulate a problem statement. Some elderly are afraid to be lonely. They want to stay connected. Step 3. Ideate. Now focus only on the problem statement and come up with ideas that solve the problem. The point is not to get a perfect idea, but rather to come up with many ideas, like unique virtual reality experiences, senior-friendly hoverboards, or a modified pushcart. Whatever it is, sketch up your best ideas and show them to the people you are trying to help, so you can get their feedback. Step 4. Prototype. Now take a moment to reflect on what you have learned from your conversations about the different ideas. Ask yourself, how does your idea fit in the context of people's actual lives? Your solution could be a combination of a new idea and what is already being used. Then connect the dots, sketch up your final solution, and go build a real prototype that's just good enough to be tested. Step 5. Test. Now test your prototype with actual users. Don't defend your idea in case people don't like it. The point is to learn what works and what didn't, so any feedback is great. Then go back to ideation or prototyping and apply your learning. Repeat the process until you have a prototype that works and solves the real problem. Now you are ready to change the world or open shop.
So this is what design thinking means, that you can formalize the problem statement and then you can find a proper solution. It doesn't mean that only a single idea need to be there. You can create multiple ideas. Okay, then you can take a feedback. Okay, what will happen if we do that? So this is like whenever we train the teachers or when our school engineers visit different schools, this is what we are doing when any projects or any competition happens. We do a ideation session with the in front of our students. So we discuss about the problem statement, and then we ask a student to give different ideas that how we can solve this problem. So some ideas are quite far-fetched. So we can have a proper critical discussion among them that, okay, this is where you are going to be stuck because this kind of technology is not available, so that they can have this understanding. Now, in this, multiple ideas can come up during this discussion, and we shortlist one of or two of these ideas, and then we combine those to create different projects. So this is how we implement the design thinking process during our like in our classes, in our learning process. So this is what we are asking about from the teachers, and also that let them explore and come up with different idea. You can give them some assignments that, okay, this is a problem statement, like you can take any problem statement from UN Sustainable Development Goals, or give them any particular task like this example that I've shown you, where the student was interacting with the elderly or with their grandparents and trying to solve the problem of how to make them move in a better manner, right? So such kind of like a small assignment you can assign to your students. When they go back to their class home, they can do an interview. Okay, so you can give them a 5-step process. That first do an interview, then have a discussion in a classroom and understand what is the problem, and then ideations can be done over there, and ideas exchange. When it happens, we can come up with one or two unique ideas on which we can work around with. So we can create multiple such projects using this design thinking approach. Now, if this student learn these concepts at a very early age, right, what will happen? They can apply these concepts in a real world scenarios when they will be in the position of solving any critical problem. Okay, and this will help them in like understanding or applying those concepts. They can have a growth in their organization. So that is why we are developing this process or this understanding. Now, there's a methodology that we use to implement the STEAM in the schools. Okay, the first process is experimentation or activity based learning. What we do, because we have understood that these students are very good in consuming the technology. Even you might have seen that your students or your child are very good in using the mobile phone or a laptop, even than you. Even you cannot know those features, and they have explored those features, right? So what is our focus? That we design some activities in such a way that it is relatable to their science concept or mathematics concept, and at the same time they can see the practical application of those concepts in a real world scenarios. So this process is called experimentation or activity based learning. Now, there's one more term that is being coined. It's called tinkering. So, sometimes during this experimentation process, there are multiple errors might uh, like occur during the experimentation. So, this will generate their tinkering mindset where they can solve that, like resolve those problems. Giving example of a coding. Okay, so when they are writing any code, so there might be an error or such kind of bugs in their code. The process is that during this activity based learning, you let them understand those problems and get it resolved. Because if you give them everything pre-cooked, they will not be able to generate new ideas. Okay, so give them a clarity that okay, this kind of problem might arise, and then you have to solve it. And during this tinkering process, they will come up with different solutions, and they will find the error that is happening in their code or find the bug that is happening in code and then modify it. Okay, so that is the experimentation process we are focusing on. The next process will be how we can apply this design thinking concept in solving a problem. So we call it project based learning. Now, the students who have understood the concept of different technology, they have become an innovator, right? So when they have understood these technology, the concept, application of science concept in a real world, they want to create their own things. Okay, so let them explore this thing by giving them some problem statement from UN Sustainable Development Goals. You can choose any of the problem statement, and you can give. Okay, this is like create some projects around the clean water or water harvesting and how you can optimize the process. So now they'll be using this design thinking approach. They'll be using the critical thinking. They will be gathering the information, analyzing the best way, and making those decision to solve in such a manner that their projects can be highlighted. So such kind of concepts we are working with. Let me give you an example like how our students are creating multiple projects and is representing their projects in different competition. So multiple of our schools are participating in different events and they are representing their students are coming up with brilliant such kind of projects. One of this project was was done uh, during the COVID time. So I'm just going to show you an example of that project. So during COVID time, one of our school students has seen this problem that the staff in the
We have also designed an app, namely
the staff in the hospitals are not like not proper, and the number of patient is very much. Okay, so what they did, they taken health and technology as a problem statement, and they have analyzed this problem. They even visited a local hospital where they have done a
Yes,
research.
we are the students from
So this is
KIT
a
University,
whole
New
process.
Delhi.
Let me show you
And
the video.
this year for 18 marathon, we have chosen the topic health tech. For this, we visited many hospitals to analyze the problems faced by the people. And here are the results.
What are the main reasons of that you are not able to provide medicines to the patient?
You can see they have done a proper interview of a doctor, like what is their problem during the COVID time, why they are facing this
So
kind
we
of
did some
problem,
research work on
and
this.
then they come up with a solution and created a robot called MedBot.
Basically, this is our
So
MedBot.
this robot can go from patient to patient, and every patient will have a medical card which will have the medical history of that patient. So they just have to show the card, and a prescribed medicine along with a glass of water will be dispersed.
Which has two mechanisms for giving out the medicines. One is for the liquid medicine and another is in the form of solid tablets. So all the solid tablets come out in its hand by the virtue of this RFID card. When the patient will press this RFID card, you will see that it would display a message, take medicine, and the name of the medicine would be displayed. And then the medicine would come out in its hand. So like here's the medicine that has come out in its hand. Now I'll press the second card and you will see that it would show the name of the medicine 1 and medicine 2, both the medicines. That would indicate that we have to take the medicine 2 and not the medicine 1. So here the medicine 2 is named Pantasoid and it has come in its hand. So by this virtue, the buzzer is for the buzzer is acts as a message to the patient that the medicine has arrived and they have to take the medicine. Now secondly, when they have to take water along with the medicine, so they can use this medicinal pump through which the water comes out. So as you can see, the water has arrived in the container that would be kept in this slot to take the water or the liquid medicine. And this medbot acts as an automatic function that would come directly to the bed of the patient, and each patient would have different RFID cards to take their medicines. Now secondly, we have also designed an app, namely medbot, which is for emergency purposes that the patients can use accordingly when they need the medicine if it's required in any urgency. So you will see when we'll press the button according to it, so we can see the working of medbot.
So this kind of projects they have done, where the robot will move around and you can control it using this mobile application. So that is what we are talking about. And if I talk about leveraging those technology in a real world scenarios, right? So what you can do, like you can teach them the concept of uh, robotics. You can teach them through a concept of coding or using the STEM concept, even the materials that is available to them, because these are the practical skills that need to be developed among the students. So to develop this application of this technology in STEM education, we have, for our teachers, for our educators, we have created a program called online certified trainer. Sorry. So we have created a program through which you can get certified in this whole technology of STEM and implementation of STEM concept in our using leveraging different technologies like robotics, coding, artificial intelligence, and machine learning. So we have a certified in trainer program. Uh, we The details of those programs will be shared with you in short while in the chat box. Okay. So from our team, Divya will be sharing the link so that you can also register to this program if you want to be a part of and understand these concepts in a better way, and start having leveraging this technology in the real world scenarios. You can apply for it for this course, and you can be a part of our innovators journey, where you can get certified by our organization. So if I talk about our organization, STEM Robo, we are a STEM.org certified company. At the same time, we are working with like we are also in collaboration with Electronic Sector Skill Council of India, which is a part of National Skill Development Program. So that kind of valuation our certificate will be holding. Apart from that, like you will be getting to understand multiple technologies like coding, where you can understand the game development, mobile application development, and even the programming of artificial intelligence also through our program. Okay, so Divya, if you can share the link and pin it in the chat box, that will be very much helpful. And before concluding this mission, this session, I want to have a picture with every one of you. So if you can switch on your camera, then we can take some screenshots of today's session. So I request every one of you to please switch on a camera. Thank you, everyone. So if you have any question or any doubt, you can put your query in the chat box. I can address it, or our team will be in contact with you to share those details with you. Okay, and we'll be sharing the certificate of for all the like participant who has attended this webinar today. So if you like our workshop, please, we have made it live on different platforms like YouTube and Facebook also. So please send your feedback over there, and we'll be doing such kind of programs in different occasions also. So we'll be discussing on different topics in later sessions that we'll be having. So thank you, everyone. Thank you, and your feedback will be very much required. Uh, so Divya, thank you very much, ma'am. Thank you, everyone. Very informative session. Thank you very much, everyone. So we'll be sending a link to register for our program. Okay, if you have, yeah. So we have shared this in the chat box. Yeah, let me just pin it for you guys. So from STEM Robot Technologies, you will be getting a chat in a chat window. So you can register, copy this link, and you can register for our certified educators program. And yeah, if someone is doodling, if you can stop. Yeah. So for more details, you can click on this registered link for educators training program, and you will get all the information required for this program by our team. And you can be a part of this innovator journey and can get a certificate and be a certified STEM educators. So thank you everyone for such a good audience, and we hope to conduct this program in a regular interval. So we will meet again with new topics that we are going to discuss. Yeah, certificate will be mailed to you. Okay, on your registered emails and mass details that you have shared, you will get a certificate shared over there.